Video we will be solving equations using logarithms, and it's important to understand that logarithms can be used to solve both exponential and logarithm equations. That's when they are appropriate to use. And before we get started with these examples, we need to understand how to work with these logarithms within equations, and we can perform the same algebraic operations with logarithms that we do with any other variable, any other number. So just realize that, for example, if I have log of 7, for example, that is just a quantity, it's a number. So if we bring in a calculator over here and we do the log of 7, you see that that's just a number, 0.845098. It's an irrational number. The decimals basically go on forever, but it's just a number, and we're just going to be able to move that around. We'll be able to take log 7, log 11, log of whatever, and just move it around like we would any other variable or number within a problem. So we can add this, we can subtract it, we can multiply it, we can divide it. Because we can multiply it, we can even distribute it. So it's important to understand that you can do all of those things just like you normally do with any variable or anything like that. Okay, so with that said, let's look at this first example. So it says 4 times the quantity 3 raised to the 0.2x equals 17. So we will be using logarithms here, and again, they're appropriate with exponential and logarithm equations. So if you have an exponent variable or you have a logarithm in the problem, then you're using logarithms to solve them is appropriate. So first thing we'll do here is divide by 4 on both sides. So we get 3 to the 0.2x is equal to 17 over 4. And now we have a problem here. We don't really have a way to get this x out of that exponent location. But what we can do once we have this form is take the logarithm of both sides. As long as we take the logarithm of both sides, it's okay to do. If this is equal to this, then the logarithm of this is going to be equal to the logarithm of this. That's okay to do. So we're going to take log of 3 to the 0.2x and set that equal to the log of 17 over 4. Once we've done that, we can start applying our logarithm theorems, and if you recall from the last lesson, we were able to take a exponent that's within the logarithm and move it to the front as a multiplier. So that's what we're going to do here. So we have 0.2x log 3 is equal to log of 17 over 4. Once we do that, we now have unlocked our variable here. It's no longer up here in this exponent location, so we can isolate it. So we basically have here 0.2 times x times the log of 3. And we discussed this earlier. This log of 3 is just a number. It's just a quantity, so we can move it around as needed. This x is being multiplied by the 0.2 and by the log 3. So all we need to do to isolate that x is divide by 0.2 log 3. Once we do that on this side, we do that over here as well. So 0.2 log of 3. And once we do that there, the 0.2 over here cancels, log 3 cancels, and we're just left with x is equal to this whole quantity. So we'll write it again, log 17 over 4 divided by 0.2 log 3. You could put this in a scientific calculator or graphing calculator and get a decimal value for it. We won't do that now. We'll just leave it in logarithm form. In this unit, we will not be using a calculator, so this is how you would leave this one. All right, let's move on to example 2. All right, example 2, we have 4 raised to the x minus 3 power is equal to 2 raised to the 4x plus 1 power. So we have these variables locked up in the exponent location here. So we want to solve for these x's here. That's what we're doing when we solve. So we can't forget about everything we learned when we worked with exponents. This is an exponential equation, so we could use logarithms, but we can also use everything that we learned when we worked with exponents in the previous unit. And that's actually what we're going to do here. Remember that when you're solving an exponential equation, if you're not using logarithms like we did before, it's all about the base. So we want to get a like base here. So 2 squared is the same thing as 4, and we're going to raise that to the x minus 3 power, and that's going to be equal to 2 raised to the 4x plus 1 power. So I've established like bases here. I need to apply my outside to inside rule right there, and once I do that, I multiply this 2 times the x and the 2 times the negative 3, so I get 2 to the 2x minus 6 power is equal to 2 to the 4x plus 1 power. Okay, once I've done that, I can take these exponents, set them equal to one another, and solve. That's how we solved exponential equations in the last unit, and that's appropriate here. So 2x minus 6 equals 4x plus 1. We'll subtract 2x here and here. This will cancel. Negative 6 equals 2x plus 1. Subtract this 1. We get negative 7 equals 2x. Divide 2. And finally, we have x equals negative 7 halves as our answer. So just remember that you can solve these exponentials the same way we did in the last unit. It's not always necessary to use a logarithm. So don't forget about everything you've learned in previous lessons and previous units about solving exponentials. All right, let's look at example 3 next. Example 3 here. We have the natural logarithm of x minus 3 plus the natural logarithm of x minus 1 is equal to the natural logarithm of 3x plus 6. Remember, ln is just the natural logarithm. It's log base e. So our goal here in this type of problem is to get it in this form. So we're using natural log, so I'm going to use this. So natural logarithm of x is equal to natural logarithm of y. Once you do this, similar to when we worked in our exponentials unit, you can actually cross out the logarithm part, because if the ln of x is equal to the ln of y, that means that x must be equal to y. So this is going to be the process that we're going to be working towards on a problem like this. So get rid of all that, and we'll apply that process to this specific problem. So we have to get it so that it looks like that form that we just talked about. We need 1 logarithm over here equal to 1 logarithm over here. Then we drop the logarithm part and solve what's left. Okay, that's what our goal is here. So we have these two on this side are added. And if you remember our logarithm theorems from the previous lesson, if you're adding 2 logarithms, you're allowed to combine those to condense them into 1 logarithm through multiplication. So that's what we're going to do here. So ln of all of this is going to be equal to ln of x minus 3 times x minus 1. So we're actually combining that, we're condensing it into 1 logarithm there. So then we have ln of 3x plus 6 still left over here. Okay, so now that we've done that, we can go ahead and we'll just FOIL this out here. And once we do that, we get ln of x squared. If you work all that out, minus 4x plus 3 is equal to ln of 3x plus 6. Alright, so now we have it looking like the form that we talked about. We have 1 logarithm set equal to the other. Once we've done that in our solving process, we can just drop the logarithm portion and set the rest equal and solve. So we have a quadratic on the left side and 3x plus 6 over here. So we need to subtract this 3x and subtract this 6 and set this thing equal to 0 and solve the quadratic like you always have. So subtract 3x, subtract 6, and we get x squared minus 7x, 3 minus 6, negative 3. Unfortunately, this one will not factor, so our only option is to put it in the quadratic formula. And if we do that, we have an a value equal to 1, a b value equal to -7, and a c value equal to -3. So if we fill out the quadratic formula, x equals the negative b plus or minus square root b squared minus 4ac all over 2a, and we fill that in for our problem, we get x equals 7 plus or minus square root of b squared would be -7 squared, that's 49, minus 4 times a is 1 times c is -3. It's all under the square root, all over 2 times a. Our a is 1, 2 times 1 is 2. So coming down here, 7 plus or minus, if you work all of this out inside here, you get 61 all over 2. And 61, we can't break that down anymore, so we actually have to, in this case, put that into a calculator to get the decimal value, and we would get a decimal value of -0.4051 and 7.4051. So the 7 plus the square root of 61 is this one, 7 minus square root of 61 over 2 is this one. So we have to, this is important to understand, remember in the previous lessons we've discussed, we cannot take the logarithm of a negative number. And if we plugged in this -0.0451, for example, right here, or even right here, we would end up taking the logarithm of a negative number, because -0.4051 minus 3 is a negative number, and that's enough right there to blow this equation up. So we can't use it. We have to reject this one. So the only answer we can accept is that one right there, 7.4051 rounded, or you could say 7 plus square root of 61 all over 2. Either way works. So that is the only one we can take. We cannot take the 7 minus square root of 61 all over 2, because it would blow this equation up, because you can't take the logarithm of a negative number. Alright, so that was a long example. Let's look at example 4. It will be shorter, I promise.